Last lesson we learned about how to differentiate log. So when we differentiate ln x, it's 1 on x. When we differentiate ln of a function, say x squared plus x squared plus 1, you have to differentiate x squared plus 1, which is 2x, over the original. Okay, so basically if I differentiate a function, ln of a function, become f dash over fx. That's what we do last lesson. Today we're going to do the reverse. We have to integrate. Okay, so we're going to integrate things. So just remember, if I differentiate ln x, it's 1 on x. So therefore, if I integrate 1 on x, integrate the derivative, I should get back to the original one, which is here. Okay, and the same thing goes if I differentiate log of a function, you get f dash of x over fx. So if I integrate this fraction, I should get back to log. Alright, so write it down, and then we're going to use this formula to do the questions, and these are on, just this one is on the reference sheet. Alright, reference sheet. Okay, write it down. Right, we're going to do some questions. So these are just the reversal of the result in derivative, okay? Alright, so basically when you see a fraction, very likely it's going to be log, okay? Now, actually, there's another reason. Now, remember this rule. Let's go back to the blank page. Actually, I've put out a blank page. Right, remember when we try to integrate x power n dx is equal to x power n plus 1 over n plus 1 plus c, right? But there's a restriction on n. Anyone remember what it is? What can n cannot be? N cannot be -1, because what happens if n is -1? You get 0 in the denominator, isn't it? So when it is -1, you get 1 on x. And we just learned that when we integrate 1 on x, what do we get? We get ln x. That's why when it is -1, I used a new formula. When it is not -1, I use this formula. Okay? Alright, so let's go to the new page. No, the previous page. Okay, alright. So let's look at this question for now. So if there's a 3 on the top, you have to take it out. Write 1 over x dx. And when we integrate 1 over x, we get ln x. So this thing becomes ln x with the 3 in front. Okay, write it down. Alright, how about the next one? What if you got 4 over 3x? You do the same thing. You just take the 4 over 3 out. So you write 4 over 3 times by 1 over x, like that. So any number, you just take it out, then you can do 4 over 3 ln x plus c. Okay, because I'm just using this rule, reversal. When we integrate 1 over x, you get log base ex, which is ln x. That. All right, well, what if you get something more complicated? You get a fraction like this. So that's when you use this formula, f dash of x over fx. So you can think of the denominator as your f of x, which is 5x plus 7. And the numerator, if you differentiate f dash fx, if you differentiate fx, you get 5. So you will get this fraction as f dash over fx. And when you do f dash over fx, the formula will become log. Okay, so you just write ln 5x plus 7 plus c. Okay. Like that. All right, good. Any question? So when you see the fraction of the form derivative over itself, it is ln of the denominator. Okay, how about the next one? Again, just do the checking. You don't have to write such a detail, so you just write it down. This is your fx. Now let's differentiate it. Let's see what we get. We get 0 minus 6x, isn't it? And is that on the numerator? It is. Once it is in the numerator, you just write ln of the denominator. So you just have to do that checking. That if the numerator is the derivative, you get the ln of the denominator. All right, good. Now, of course, not every time they will match. What if they don't match? What do you do? You can still do the question. You just have to make some changes. So, okay. All right, okay, good. So let's move on to the next question where the numerator doesn't work. So we're going to write f of x. Oops. So f of x is the denominator. Okay, let me just try to do that again. Okay, f of x equal to x cubed plus 3x. Okay, now if I differentiate it, I get, that's your fx. If I differentiate it, you get 3x squared plus 3, right? Now, obviously, this is different from the numerator, but they're not completely different. They look very similar. Because if I take the common factor 3 out, I get 3 bracket x squared plus 1. All right, so let's take this off. Okay, all right. So you got extra 3 in front. You got extra 3 in front. So that means I need to put an extra 3 in front of the integral. So let me write this again. Integral x squared plus 1 x cubed plus 3x dx. And then what you do is, see that you need an extra 3 in front. So it will give an extra 3 so that the numerator matches the derivative of the denominator. Okay, but I can't just add a 3 there because that means I changed the question. So in order to offset this, I just have to times by the reciprocal. So you add a 3 and put 1/3. So 1/3 times 3 is 1, so you go back to the original. But by adding the 3 now, the numerator is a derivative of the denominator. So therefore, I could just write 1/3 ln of the denominator. Yeah, like that. All right, good. Any question? All right, you can do the same thing for the next one. Have a try. So differentiate first, see what you need to add. So we'll write f of x, which is equal to 2 minus 3x. And then you're going to differentiate, which is negative 3. All right, I want negative 3. This is 6, isn't it? So what you could do, you can write 6. Just take the 6 out first. You don't have to take the 6 out. You can take the 2 out. But I'll just take the 6 out. And what you need to do is, this is negative 3. So put a negative 3 in front and divide by the same amount. Right? And then this becomes negative 2. So it becomes negative 2 ln of the denominator. All right, get the idea? And there's some definite integral we could try on the next page. All right, write it down. Okay, all finished. Okay, good. Let's go to the next page, definite integral. Okay, so if it's a definite integral, you do the same thing. You write ln, I actually write 4 first, take the 4 out, like that. And then you write 4 ln x, 9 and 3. And then you're going to substitute 9 minus ln 3. And then using log law, you can, when you subtract, it's same as divide. ln 9 over 3. What's 9 over 3? 9 over 3 is 3. Like that. Alright, try the next one. Have a try. Alright, next one you do. Now next one, it's a fraction with more complicated denominator, so what you need to do is to differentiate it. 2x squared minus 5x is equal to 4x minus 5. That matches with the numerator, match. If it's a match, you can write ln of the denominator, put square brackets, 6 and 3. And then you substitute 6, ln 6, substitute 6, you get 2 times 6 squared minus 5 times 6, minus ln 2 times 3 squared minus 5 times 3. And then you work out 2 times 6 squared, 18, no, 36, okay. You just use your calculator. So 2 times 36, 72 minus 30, get 42. And the other one is, what's the other one? 9 times 2, 18, 18 minus 15 is 3. ln 3. And then you get ln 42 over 3, which is, you can simplify. I think the answer is ln 14. Right, all done. Okay, good. Alright, after we do all the integrals, we need to find the area and volume by the volume of solids of revolution. So we'll do this. Okay. Alright. Let's look at the first one. So now we can find the area bounded by the hyperbola. This is a hyperbola, which I drew over here. Right? And then you want to find the area bounded by the two parts, x equal to e, x equal to e squared. Let me write it down. That's e squared. You want to find the area here. And to find the area, you write down the general formula. It's equal to y dx from a to b. And for this question, the limits are e to e squared, and the y is 1 over x. Okay? Like that. And then now you know how to do it. Just find the primitive and substitute the limits. Okay, alright, good. So you get ln 1 on x is ln x, e squared and e. And then you get now e squared is ln e squared minus ln e. Now you can use the log law, the e squared. Actually, I should do it on the top. Alright, so you get ln e squared minus ln e. ln e squared, the 2 goes down. So that 2 can be brought down by the log law. And then we know what ln e is. ln e is 1, which is 1. Is your answer. So the area is exactly 1. Area is exactly 1. Square units. square units. Alright, done. Okay. Okay, what's after this? Find the area of the region bounded by the curve. This one we can't sketch. We can sketch, but it will take a long time, so you just do it without sketching. So you can just go from 1 to 3, y dx, and just work out. Okay, just try to work out. Have a try. Okay, so what you do is this. So we're going to differentiate the bottom. So if I differentiate the bottom, I get 2x. And we need a 2 on the top. So if you need a 2 on the top, you put a 2 here, you put a half in front. So you end up getting half of ln of the denominator, put a square bracket, 3 and 1, and work out. So substitute 3, you get 10. Substitute 1, you get 2. And then you get 10 over 2, which is 5. So half ln 5. Like that. Alright, half ln 5. Alright, next one. Once we find area, we also have to find volume. And how do we find volume? There's a formula for volume. Pi y squared dx from A to B, because that's the volume of the solid form by rotating the curve about the x-axis between these two parts. So we're going to write pi from 6 to 11, square the function. Oh, I forgot to copy mine. Right. Okay, so you get root x minus 2 square dx. That, and then you can work out. Okay, let's continue. So if I do that, you get pi integral from 6 to 11, 1 on x minus 2 dx. And then you get ln x minus 2, 11 and 6. And then you get 11 minus 2, you get 9. Minus 11, 6 minus 2, you get 4. So the volume will just be pi ln 9 on 4 cubic units. Okay, done. And then we've got one more question to go through. Alright, all good? Alright, now we can also now find the area bounded by the log graph. Let's look at this. Log graph. Okay, area involving logarithmic graph. Find the shaded area bounded by the ln x, x-axis, y-axis, and the line y equal to 3. So when you find the area bounded by the y-axis, use horizontal rectangles. So in that case, if you add up all the horizontal rectangles, it becomes x dy from A to B. That's the area, right? So what you do is, and the limit's going to be y equal to 3, like this. And then, okay, good. So what you do is you're going to go x is, yeah, you have to make x a subject. So y is log base ex, and you have to write it in index form. E to power y is x, so e to power y dy, but the limits will be from 0 to 3. And then you can integrate it. So you can integrate exponential. Exponential will just be e to power y. And then you put in the limits, 3 and 0. And then substitute 3, which is e to power 3 minus e to power 0. E to power 0 is 1 square units. All right, done. That's the area bounded by the y-axis and the graph. Now things get a bit harder when the area is bounded by the x-axis. Let's see why. So the next question is, find the area bounded by the x-axis. Let's write it down. So bounded by the x-axis and the line x equal to 5. Now what's the x-intercept of the log graph? 1, very good, because ln1 is 0, right? Okay, so normally what you do is you use the vertical rectangle, so the area is y dx from a to b, which is from 1 to 5 ln x dx. But there's a problem. We don't have a formula to calculate the integral of ln x. We can only differentiate it, but doing backwards are different, because when you differentiate, unlike the exponential, we get a different function. So we can go backwards, but we can't go backwards after that, isn't it? So we can go backwards from 1 on x. If we integrate, we go back to ln x. But if I integrate ln x, I don't know what that is. Okay, so what you do is, this can't be found in extension 1 level or at tuner level. So what do? Maybe what we do is this. We're going to instead find the area bounded by the y-axis, because we can do that, isn't it? We just did that already. Find the blue bit. Let's find this blue bit. Let's call that B. So the area of B will be from x dy, right? X dy from A to B. And what we need to do is to work out the y value at 5. And the y value at 5 is exactly ln 5. Okay, so what you do is you write down from 0 to ln 5. X is now e to power y like we did before, because y is ln x, x equal to e to power y. Okay, and then we can find the primitive, because finding primitive of exponential is easy. It just becomes e to power y, ln 5 and 0. Okay, now we substitute. Hopefully you still remember what this is from yesterday. What's e to power ln 5? 5, because the e and ln gets cancelled. What's e to power 0? 1. So the answer is exactly 4 square units. So the area is 4, but that's not the area of the green bit that we want to find, right? We want to find the green bit. So how do you find the green bit? To find the green bit, which is what I'm going to do here, the green bit equals to, you can think about the rectangle here, subtract the purple bit. Right? So what's the area of the rectangle? Length times width, so you get 5 by ln 5, right? So the area will be 5 times ln 5, length times width, minus the area of the purple, which is 4. Yeah, that's the answer, okay? That's the area of the green. Square units. All right, any question? So when the question asks you to find the area bounded by the log graph, use this method, okay? So make sure you find the area bounded by the y-axis first, because you don't want to integrate the log. You can't integrate log. So you find x dy and then subtract from the area of the rectangle. Okay, so next lesson we'll do a revision of this topic, and then we'll start a new topic next lesson. Okay, all right. Now today you do 4.8 today. Thank you. 再